Kimi K 2.5 is out, and it's the new big hot model. Can it run on this? Well, yeah, that's what we're gonna do today. This model is 658 gigabytes on disk, so it needs to be sucked up into memory and be available for us to be able to query it or use it as a coding assistant. Well, unfortunately, one of these Macs only has 512 gigabytes of memory. Unfortunately. I mean, fortunately. It's pretty good. I'm borrowing these from Apple, okay? Relax. This is almost $50,000 worth of Macs. Each one of these has 512 gigs of memory. And yeah, Kimi K 2.5 can run on 2 of these, but we can do better. What do I mean by that? Well, here is an example of Kimi K2 running on Alex Chima's desk using EXO. So this person confirms that this will run on 2 Macs because total is 1024 gigs, which is good enough. And here's Ani, one of the people that works on MLX, the optimized framework that runs on Apple Silicon, running Kimi K2 on 2 M3 Ultras, which is what I have here. And he's getting 15 tokens per second using pipeline parallelism. Now this is the 4-bit precision. Let's see what I get. Boom. Check out the monitors right there. I'm getting 2 out of the 4 machines working right now, and I'm getting 100% GPU usage. The model is not loaded yet. It's still loading. And these 2 are just sitting there lazily. Don't worry. We're gonna use them in a moment. Look at that memory filling up right there. We're up to 260 gigabytes on each machine, 270, and this is not using EXO. This is using MLX. MLX has now distributed support for using RDMA, which is Remote Direct Memory Access, through Thunderbolt. That means these machines can talk to each other by having all of them connected through Thunderbolt and skip the networking step, so the GPU can talk to each other directly and use that massive amount of unified memory that's available to these Macs. All right, it's done now. You can see the chart right there. That's the usage history for the GPU. And we got 23 tokens per second. We almost caught Ivan, who got 25 tokens per second. Oh, but he's running the 3-bit version. We're running the 4-bit version. So a little different. Now, what if I run it on all the machines? One of the benefits of using this technology stack, it scales better. And I made a video about this not too long ago. That video was more about EXO because EXO makes this setup a little bit easier. However, with EXO, not all the models are available. That's why I want to show you this repository I created that'll show you the setup from scratch, how to connect your Macs, how to set up your environment, how to create a Jackal host file. Jackal? Don't worry, we'll get into that. Boom. Now we're gonna see activity on all the machines. Look at that. All the machines now have their GPU pegged at 100%. And now this gigantic model is gonna be loaded across all the machines. The first time I had to answer what happened on this PC, I knew some of the tools, but I didn't actually understand the artifacts. That's why I've been watching video courses on the 13 Cubed YouTube channel. This is 13 Cubed, premium practitioner-focused digital forensics training without the premium cost. They have a YouTube channel, and the free content is opposite of marketing fluff. We're talking deep technical breakdowns and real forensic analysis that you can watch right now. The paid courses go way beyond free videos. Hands-on investigations with realistic evidence, triage collections, disk images, and memory captures across Windows, Linux, and Mac OS. And the certifications are practical for the same reason. You don't just answer multiple choice questions. You're given realistic evidence like disk memory captures. You analyze the artifacts, build a timeline, and answer investigative questions the way you would on a real case. Right now, I'm in the paid Mac OS course, and it's teaching me how to find artifacts, not just what the answer is. This one uses a day-by-day threat actor timeline so I can validate my work. And there's a built-in comments section where I can ask instructors questions directly, plus a community forum for students. And the value prop is honestly wild compared to the $10,000 you pay for similar courses elsewhere. Your access is 365 days, so you can renew later at a discount, and your cert is verifiable through a third-party service. So start with a free 13 Cubed YouTube channel, then check out the courses and the certs with the link below and use code ALEX26 for $100 off any course or bundle. Get premium cybersecurity training without the premium cost. Link below. Now, before Apple introduced RDMA technology into this stack, the more machines you add, the slower it's gonna be, but not anymore. All right, we're almost up to 200 gigabytes on each machine, and it's done. And look at that, 29 tokens per second. We got some speed out of this. 29 is pretty usable. Why is this important? Well, yes, this is almost a $50,000 cluster, but you could get away with just using 2 of these and still get 23 tokens per second. And if you use a different model, not Kimi, for example, another really good coding one, GLM 4.7, you can even run the 8-bit version of that, which is less quantized, so giving you a little bit better quality theoretically. That's 375 gigabytes. You can run that on one. In fact, I haven't tried that yet. Let's see what the speed of GLM 4.7 8-bit is on one machine. There it is running on one machine only. It's got to load all that 375 gigabytes into memory. Boom. We're getting 14 tokens per second. Not amazing. By the way, Kimi K 2.5, yeah, it's a 1 trillion parameter model, but it only has about 30 billion active parameters, and so does GLM 4.7. So even though GLM 4.7 doesn't have as many parameters, it's still pretty heavy. And this is the 8-bit version. That's why you're seeing it slower. What if we do all 4 machines now? Can we beat 14.2 tokens? And I'm gonna invite you to take a guess in the comments right now. I think you might already know the answer to that. Look at it running on all the machines. Now, while it's doing that, here's another reason why Mac Studios are actually Apple Silicon in general is pretty decent for doing this kind of thing. We're using 283 watts of power, 290 now, for running all 4 of these systems at the same time at full blast GPU. And when it's not working, when it's just sitting pretty, we're at 92 watts of power, and that could be just because it's a little agitated right now. We've poked the bear. 23.7 tokens per second here. What does that actually look like when you're using it? Does that actually work? So here I am in VS Code, and I have one of my machines, the endpoint, exposed to the network. That's on port 8080 of this IP right here. Everybody's is going to be a little different, but let's query that model's endpoint. And yeah, we have one model running, that's GLM 4.7. And by the way, this is a server that I created so that it's easier for you to get started with this MLX distributed situation. I'm going to use a tool called OpenCode. You're all probably familiar with it. And let's go to models. And there's my local llama server. I'm going to pick GLM. Let's just do a little query, shall we? And watch that screen so that you'll see how this works and how quickly it'll respond to me. What is your favorite programming language? Language, whatever, it's fine. And now it's going out to the servers. You can see that they're all working on this little problem that I gave it. They're all thinking at 100%. Now, if you're using like Opus or Codex, to be honest with you, it'll probably have an answer by now. But this one thinks a little bit longer. Also, my server is kind of simple. It doesn't have the model loaded all the time. It doesn't have the cache. So all those things play a role here, but it's a very basic way to set things up. I'll show you that momentarily. And it is answering me my favorite programming language, blah, 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 JavaScript and Python and TypeScript. So it's very heavily leaning towards web devs. But you saw how long that took to answer. Is that usable? That's up to you. Is Kimi K2 gonna be slower? It's gonna be about the same, I'd say. Now, I launched that server with GLM 4.7. I also happen to have another model here, Qwen 3.4b, my favorite one to test with. And stop complaining to me that nobody uses it. Look at that, 3 million downloads. You know why? Because this is a good model. It's small and it's useful for things like speculative decoding. That's gonna be another video though, not now. But you could actually use it if you wanted to. I'm just not sure it's gonna give you the best answers that you're looking for. Certainly not better than Opus 4.5 will give you. So I'm gonna quit OpenCode, restart it, select the new model, and say, well, what's your name? Boom, there it goes, it spins up, and it says, I'm OpenCode, your assistant. I mean, that took almost 0 time. We couldn't even catch it. This model is 8 gigabytes in size, so it's tiny. It's embarrassing running it across a cluster like this, but it is fast. And you know what's interesting? If I run it on one node, there it is, I get 166 tokens per second. So fast that I didn't even have time to look over there. If I run it on 2 nodes, boom, 170 tokens per second, faster. And if I run it on 4 nodes, any guesses? 4 nodes, boom, 175 tokens per second, even faster. So yeah, there's some benefit to having a cluster now that we have RDMA. All right, enough of this. You've seen the demo, let me show you what we're doing. I created this repository, MLX Jackal Cluster. This is a set of tools to let you get up and going with this quicker than you would if you had to read all the MLX documentation like I did, and Claude did. Claude helped me out here. quite a bit. I'll admit it. I use it for everything now. The README file has basically things that are just quick if you already have something set up, if you have a Conda environment. If you want everything from scratch, you go to the docs and from scratch right here. This will show you how to connect your cluster of Macs, whether you have Mac Studios, if you have Mac Minis, how to wire them. You have to enable RDMA on the command line. And then once you do, IBV devices is what you run to verify it. Those are your IBV devices. Basically, it means RDMA is enabled. Now, you create a Conda environment. This is the name of it right here, MLXJCCL, Jackal. It should have been Jackal with an A, but oh well. But anyway, it doesn't matter. That's going to be the name that you pick, and you're going to stick with it. Could be anything. You install Python, you activate the environment, and if you don't know what I'm talking about, Conda is a way to manage your Python environments so that you don't have different versions of packages installed all over the place. It's going to keep everything nice and neat together. I have a separate tutorial on Conda environments and setups, and I'll link to that down below. And also for members of the channel, I created a separate UV tutorial. UV is like a separate tool for managing your Python environments. Then you install these packages, you verify that everything's installed, and you do this on every single machine in the cluster. And then you have to pick one machine, rank 0 coordinator IP. It's a fancy way of saying basically your first Mac Studio is gonna be on the LAN on your local network, and it's going to have a DHCP IP assigned to it. Basically, that's the IP that we use to run curl commands and also set up in your configuration for OpenCode. For example, here's mine, 0.36. You do that just by running this command right here, and that gives you the IP address of that machine. Then you create a Jackal host file. This has the name of your hosts. So you want to name these things probably something similar so that you can easily remember that. Mine is Mac Studio 1, Mac Studio 2, Mac Studio 3, and Mac Studio 4. All of them have a .local address. So if I type host name, this is the one I'm connected to right now, Mac Studio 1.local. Now, if I go to hosts.json, you'll see all the host names listed here in a JSON format. So here's the SSH, Mac Studio 1.local, Mac Studio 2.local, Mac Studio 3, and the IPs array is empty for all of them except for the first one, which is going to have that local LAN IP address. And finally, the RDMA array has your connections on the back that are actually connected to other Macs. So for example, in this first one, I'm connected to the second, third, and fourth through these RDMA interfaces, basically the Thunderbolt connections on the back. But just go according to the diagram and you'll be fine. Now, once you're set up, you verify the cluster by running this command. It's another script I included here. And it just goes through and it makes sure that we can connect to all the machines through SSH. You also need to enable passwordless SSH on all the machines so they can all talk to each other without using a password. So that's what this checks. And then this makes sure that all these are RDMA capable devices. Next one is gonna take a while. You're gonna have to download the models. So I suggest starting with a small model. That's why I have the Qwen 3.4b. Really small model, really easy to move around. You can use the Hugging Face CLI as an example, which is what I did here. But make sure that you're grabbing that model and putting it somewhere you know is gonna be. If you omit this local dir command, flag, it's gonna put it in the Hugging Face cache and you're never gonna find it. You may know where to find it, but it's a pain. So include this local dir command and point it to where you want your model to live. Mine all live in this models MLX folder. Once you have that on one machine, you're gonna wanna use an external SSD so you can copy the model to all the other machines in the same exact location. That's important. If you don't do that, if you use FCP, it's going to take forever. You can also store the model somewhere on a NAS device. And I've shown videos on this channel of that working. You can, but that's going to take forever. Again, this is the fastest way. Do it this way. Trust me. Especially if you have gigantic models. By the way, if you're using EXO, the same thing goes for EXO. Copy the models with a drive from machine to machine to machine before you kick off the models in the EXO dashboard. Use the script to verify that you have the model in all the machines. And then this is that benchmark that I showed you before. Include the host file, include the model right here, the model directory, and then you can give it a prompt also, change the max tokens, mess around with this. But here are two important things. This one right here, you want to make sure that you're using RDMA. So you want to have the MLX Metal Fast Sync flag on and disable the Hugging Face hub by using this HF hub face offline equals 1 flag. And same thing with the transformers offline equals 1. The reason you want to use those two is so that the script doesn't go and try to automatically download those models to all the machines. Again, it would take forever. We've already manually downloaded the models and we're giving it the model path, so we don't need Hugging Face to go and download it for us. Here's the TPS bench. So that just gives you an idea of how quickly tokens per second, and it's gonna validate that everything is working on all the machines for you. Finally, when you're ready, then you can start up this server. This is the script for the server. You pass it the model, you pass it the run OpenAI cluster server.sh script. You can also change the port, you can change the host file if you want to, and run that. Now, this is a very basic server. All right, that I just created. You have the models endpoint, so you can check which models are installed. You have the chat completions endpoint, and you have the V1 completions endpoint. Now go and play with this. Go on, play with it, start this repository, enjoy. And if you have any pull requests, I welcome them. Thanks for watching. And if you want to see that whole video with EXO, watch that right over here, and I'll see you next time.